from Mr. Nicholas's basement. We are now in the process of doing an example of kinetic theory. So the first example that we're going to do for you is a pressure gradient. And I'm going to take this bottle and this hard-boiled egg. Now the shell is off the egg, okay? It's not, this is like soft, and I'm going to put it on there, and I'm going to have the air molecules in the room push this egg into this jar. Okay, so this is like something that you could do at home. If you have a jar, you can make a hard-boiled egg. If you know how, it's about a 10-minute boil, and then you just let it cool down, take the shell off of it, and you're all set. And then I'm going to take a piece of paper towel. I'm going to light it with a lighter, and then I'm going to put that in the jar. Now what's going to happen is this jar is going to get hot because there's a fire in there, and particles are going to start moving faster. We learned that again when we were doing heat, and they're going to start escaping. Okay, it's going to create a high pressure in there because of the speed of the particles. Now, these particles are going to leave the bottle. Then I'm going to put the egg on top. The oxygen is going to burn out. We're going to create some carbon monoxide down there, and what's going to end up happening is that molecule that's created from the burn. And I'm not a chemist, I'm not trying to tell you how all that stuff works, but as those bonds change, those cohesive and adhesive bonds change from oxygen and nitrogen to the carbon dioxide, carbon monoxide, whatever else is in there is more dense. So two things are going to happen. When the fire goes out, the air is going to cool, so the particles are going to move slower. As they move slower and start converting themselves into these other molecules, the air in here is going to become less dense than the air out here. Now, density means they're going to get closer together. That's going to create a huge vacuum in there, a huge void. And in pressure gradients, high pressure always goes to low pressure. So what's going to happen is the air on the outside is going to push this egg into that bottle. Now, I'm going to actually do that for you. So this is kind of what you'll be doing for me. You don't have to be maybe as talking about it as much. You can see that's getting hot. I'm going to put the egg on it. Boom! And down she goes. I know y'all want to see that again, don't you? Well, just hit your record button and you can watch it 100 times. Oh, look at that. I started a fire in the house. So the next thing, that's good that my fire extinguishers work. The next thing is, how does this relate to kinetic theory? Now remember, kinetic theory is all objects have minute particles, they're in constant motion, and they have cohesive and adhesive bonds. So number one, we had a lot of air particles in this tube. Okay, part number two is that they got hot and they started moving faster and leaving the jar. Because it was a high pressure in there, they go to the low pressure on the outside. When I put the egg on top, I created a pressure in the bottle where the flame went out, so the particles started moving slower, and the bonds started changing. Instead of being air molecules, there are carbon dioxide, carbon monoxide, whatever that molecule is, more dense. They shrink down. Too much room down here, low pressure. High pressure goes to low pressure. Boom! And down she goes. I guess I'm not going to be able to start many more fires in here.